Troubleshooting route maps and policy-based routing. Policy-based routing is essentially a programming language for your routing table. So essentially it looks at the router and says, well, I know your routing table says to do this, but I want to make an exception. There's all kinds of reasons to do this, and I've been in many situations where I'm working with non-Cisco equipment and it doesn't do policy-based routing, whether it be a layer 3 switch or a router. It's one of those features that you only seem to get in the high-end devices, the higher-end devices, where I can say, well, you know what, if this guy comes to the router, send him to ISP1, but if this guy comes to the router, well, then send him to the ISP2. And this can take 1,000 forms. I know I'm just giving you one silly example of two computers right here, but I mean, just take it to something that we run into every day, public Wi-Fi, right? Maybe you've got a little DSL connection that you use for your what I'll call junk internet, right? Where people that join your guest network or something that's not managed, they can automatically go out to the DSL connection, whereas the other people, well, they've got the managed T3 service or whatever you're using for your higher grade internet connectivity, right? Well, how do you do that with a single route table? You can't, right? You only have one default route. That's where policy-based routing comes in and says, okay, based on who you are and what the policy says, we can route you differently. Let me give you a quick example. Everything policy-based routing is implemented using a route map, right? If you're not super familiar with route maps, they are very easy to get used to, very much like an access list. So I'm going to go into global config mode and do a route map, and we'll call it policy. Right? You can name it whatever you'd like to. Then you have your sequence numbers, just like an access list does. I can go in and say sequence 10 and press enter, and by default it will make it permit 10. Permit is the default action unless you tell it otherwise. And I'll explain permit and deny in just a second, but let's stick with 10, right? By the way, if you don't type in a number, you just hit the enter key right there, it automatically increments in chunks of 10 as well. Okay? So I'm going to go policy 10 and we'll say match. Actually, I jumped too far ahead of myself. You need to essentially a route map is the last step. It assembles all of the different pieces together into a congruent flow. So I'm going to go create an access list. Do IP access list. We'll make it a standard access list, and we'll just say DSL users. Right? Now permit the IP address. Well, in this case, or the permit, I'm thinking I'm speaking what I want to do, but typing obviously doesn't work. Permit the host 192.168.1.21. Now, I'm going to say that this host represents public subnets. It represents all kinds of different things, right? So you could permit anything. And I also want to broaden your mind here as well. You could make this thing even match port numbers. I'm using a standard access list. But you could go create an extended access list, and you can say, you know what, all of our email traffic, stuff using SMTP port 25 or maybe port 110, POP3 or whatever, goes across the T3 line, where all of the HTTP and HTTPS traffic automatically goes to DSL. You can get that granular if you really wanted to. Anything an access list can match. I mean, time of day, there's all kinds of things you can do with it. It's fun. You can do it. So we'll exit out of that, and then we'll say IP access. Well, actually, let's leave it at that. I'll explain why in a second. Go back into my route map. Policy 10. And I will say match, and you can see this is where you can match all kinds of things. Route map, by the way, if you can't tell from this question mark, is huge into BGP. This is how you set just about every BGP attribute. But we're going to say match the IP space address, and then we'll put in the name of the access list that we want to match, which is going to be the DSL users, right? Right there. Enter. Now it says, okay, I'm going to match those guys. What do you want me to do with them, Jeremy? And I'm going to say, well, actually, I want you to set, and this is where we have all of our options that we can set with the access list. Again, many of them related to our friend BGP, but we're going to say set the IP next hop. And this is where we can say a specific interface or the next hop IP address, which if looking at this diagram, it looks like our DSL provider is going to be 201.1.1.1. Because there's two 201.1.1.1. Oh my goodness. Just a second. Actually, you know what? I can just fix that real quick. There it is. It's like, what is that? Ace Ventura Part 2. He climbs to the top of the mountain. The great gold medallion. This took you 30 years to achieve. That's okay. I like it anyway. Anyway. All right. So we're saying the next hop IP address is 201.112. Let's do a show route map. Right? Let's put those puzzle pieces. Oh man, we got to undo one of them right there. Yeah, let's get back into that route map and do a no. There we go. Now we'll show our route map. There we go. So it says, okay, sequence number 10 is going to match the IP address DSL users, and then set, if they essentially match that, set them to the next hop IP address 10.1 or 201.112. Right? Now, food for thought on this one. Okay. Before I actually do the other side of the equation, which is the one that goes to the ISP1, what happens? Well, first off, how do we apply this? And then what happens if something doesn't match? All very good questions. Let's go into fast Ethernet 0/0 because we're going to match this thing on the incoming. Remember, if it's going out, it's already too late. It's already made its decision of which interface it's going to use. So we're going to match it on fast Ethernet 0/0 as it's coming in right there. I'm going to do IP policy route map, and we'll put, what do I call it? Just policy, right? I think if I remember right. Yep, route map policy. Hit the enter key, and now it's accepting it. The access list, everything that's inside of it, determines the flow. So as things are coming in, it's going to say, okay, I'm matching those DSL users and then setting their next hop to this. Okay, so right now, Jeremy, what happens if, let's just do a show route map again. What happens if the 192.168.1.21 user comes in, right? Let's use the one that we know about. So this guy comes in. He's going to hit the router. It's going to go, okay, there's a policy route assigned to me, or a route map assigned to me called policy. It's going to say, do you match this DSL users? Oh, you do. Great. Let's set your next hop to this, and whoop, send you out the rest of the way. Right? And off he goes routing on his merry way to ISP number 2. Okay, well then, Jeremy, what happens if this guy comes in? He comes in. Okay, great question. What happens is it comes into the route map and it says, okay, are you part of this DSL users access list? No, you are not. Okay, you don't match this. Hang on, where's my pen? You don't match this square anymore. There we go. So I'm not going to policy route you. That doesn't mean it's going to be dropped. Did you catch that? It says I'm not going to policy route you. So I'm going to drop you back out and route you using the normal routing table. So if you have a default route pointing to ISP1 already, you don't need to add another line to this route map. Because as soon as it realizes it's not a public Wi-Fi user or whatever you've defined a match using an access list, it's going to say, okay, I don't match. I'm going to fall back to my normal route processing. Okay. Well, what if I wanted to catch everybody else in this route map? Well, here's what you can do. I can go route map, policy. Nope. Policy, right? Permit 20, right? I can then come in and just do set IP next hop address 200.1.1.2. Right up there. No match statement. Did you catch that? Show route map. Look at this. I now have two sequence numbers, one with a match clause, matching this IP address, one without a match clause. If it doesn't have a match clause, I should say, it matches everything. So now, essentially, if it's not the DSL users, it's going to fall down to sequence number 20, and it's going to set the IP next hop to this one. So that saves you from having to create an access list that matches everything else, right? It also saves you from having to fall back to the normal way of routing. Now, before I forget, you can also put deny statements in this route map. I could, come in here and do a route map policy deny 15, kind of squeeze it right in the middle and do some match, such and such and such. Put whatever in there. What that does is deny it from route map processing. Again, when we think permitted deny, I mean, we typically think of an access list applied to an interface where it's literally allowing or denying packets from getting through, right? Well, in this case, it's permitting or denying things from matching the route map. So if it gets denied, again, it doesn't fall off as if it has been blocked. Instead, it's going to drop out of the route map processing and go back to using the normal routing table. Does that make sense? Now, what if, I know there's so many questions that can come into this thing. What if I wanted to deny them? Well, if that's the case, then we can set an exit interface of null 0 or something that puts it to the garbage can, essentially. There's also some drop commands in the route map as well, but that should give you the flyby of what route map and policy routing is all about. Well, where can policy routing go wrong? Well, honestly, most of the time, I just forget about it. I'll set it up for a customer, come back a year later, and be troubleshooting some weird issue. I can't figure out why it's happening until I rediscover, oh, that's right, we put this in place. That's why it's hosing us up now. Remember, every single time you do policy-based routing, you're making an exception to the rule of routing. This is not a feature that you would want to rely on. It's more of a band-aid than anything else. So try to do routing the right way as much as you can and use policy-based routing as that crutch when you get to those bizarre circumstances that you can't just get a blanket rule for, right? So otherwise, not understanding route map rules, understanding that these things are like access lists, top-down processing. As soon as it finds the first match, it exits and doesn't process any further in the list. So if you have multiple matches, it's not going to see them. There is an implicit deny all at the end. That is what I overruled by putting in that match all at the end. But deny all doesn't necessarily mean that the packet will be denied. It's just denied from route map processing, right? The policy could be applied incorrectly. Maybe you assigned it to the wrong interface. Maybe you don't correctly understand permit and deny in that route map. Especially, I mean, think about how confusing this can get. You got, route map, let's just say policy, permit 10, right? And then underneath there you have a match that uses an ACL, which also has a permit or deny, right? So you could have a permitted statement which is denying 192.168.1.5, whereas you could have a deny statement which is denying, you could get double negatives, positive I mean, it can blow your own mind. That's why I, as a rule, say never use deny unless there's absolutely no other way around it. Always do a route map command with a permit statement so you don't melt your own brain trying to put together the cocktail of access list plus route map, permit, and denies together to figure out what it actually comes out to. And they do, by the way, combine together. It's like if I have a deny and then I deny in the access list, then, well, it's denied from being denied, so then it's permitted. I mean, it messes with you, so don't go there. You could have the wrong set parameter. Maybe you set it to the wrong IP address, or you set some attribute that you didn't plan to set. You saw, for instance, I set the IP address incorrectly at first and then went back to fix it, but forgot to remove the first one. So it actually had two set statements in there with two different IP addresses. So you want to make sure that you always know what's underneath that set command. We've seen some of the commands that I've put in here so far. The beauty of, let me get this over here. The beauty of the show route map, there we go, is we'll actually be able to see how many times we've had a match on these statements, right? So you can tell when it actually is going to do some policy-based routing. You can do a show IP policy because the show route map just shows the route map generically. This will show you where the policy is applied. I should have came up with a different name for my route map other than policy, but you get the idea, right? So I've got the policy route map applied to fast Ethernet 0/0. I could also do a debug. I could do debug IP policy and actually watch packets as they match this policy go through. Matter of fact, I set up a little PC behind the scenes. Let's hang on. Let me look at that diagram one more time. Right there. Let's give it the IP address 192.168.1.21, right? So we'll do set IP. Hang on, set IP. I always forget the syntax. Set. I think it's just set IP 192.168.1.21/24, and then you give it the gateway 192.168.1.1. No. Wait a sec. What is it? The virtual simulator in GNS3 set IP set. Oh wait, no, just IP. There we go. Let me hit the up arrow. There we go. And back, all the way back here, and all the way to the end. Enter. There we go. All right. So now we'll bring this interface up. Ping 192.168.1.1. Good, we're getting there. Okay. So now let's see if we can ping through, and we'll see if we catch the policy routing take effect. So this guy, let's just do. It's not going to succeed because they don't actually have any public IP addresses. But let's just ping 4.2.2.2, and we should see. Look at this guy. It says comes up. Looks like we've got the source address right here, going to the destination 4222, and it's coming up and saying forwarding information base policy routed. So that policy routing is taking effect. Obviously, You want to be careful with that command if you're using this on a very busy network in the real world, because that can swamp your router and cause it to crash. That is how you can work with and troubleshoot route maps and policy-based routing. I hope this has been informative for you, and I'd like to thank you for viewing.